Welcome back to Minute Micro Macro. Today we're looking at, can the price of one good affect the demand for another? So let's get started with some revision from the previous lesson. We were looking at PED and YED in the last two lessons. A corner shop increases the price charged for a chocolate bar from 40p to 50p, but sales fall from 450,000 chocolates per year to 270,000 chocolates per year. Calculate the PED to two decimal places. Well, before we can calculate the PED, we need to work out the percentage change in price. So it's 10p divided by 40p times by 100, and that is a 25% increase. Then we also need to work out the percentage change in quantity demanded. We know that the sales fell from 400,000 to 270,000. So we're going to do new minus old over old times by 100. So it's 270,000 minus 450,000 divided by 270,000 times by 100. And that is a fall of 66.6%. So our PED is percentage change in quantity demanded divided by percentage change in price. Our percentage change in quantity demanded was negative 66.6, and our percentage change in price was 25. And so that gives us a PED of negative 2.664. But as always with PED, we are looking at the absolute value. So that's 2.664 as our PED. This gives us a value that is greater than 1, and therefore we know that the PED of that good is elastic. So we know that there's going to be a greater than proportional change in quantity demand as a result of a change in price for chocolate bars. And just to be precise, the question does in fact ask for the answer to be given as two decimal places. So PED is equal to 2.66. Okay, for the second question to get us warmed up, we're looking at YED, income elasticity of demand. Weekly incomes increased from £500 to £525. The demand for bread increased from 1,000 loaves a week to 1,010 loaves per week. A local shop calculates the YED. So the percentage change in income is an increase of 25 divided by the original 500 times by 100 gives us a positive increase of 5%. The percentage change in quantity demand is equal to 10 divided by 1,000 times by 100, and that is an increase of 1%. So our YED is calculated by finding the percentage change in quantity demanded divided by the percentage change in incomes now. So the percentage change in quantity demanded was 1%, and the percentage change in income was 5%. So this gives us a YED of 0.2. Now, because that is a positive number, and for YED, positives and negatives do matter, a positive YED tells us that it is a normal good. And so that means that when incomes increase, people consume more of it. However, because that YED value is between 0 and 1, it tells us that these goods are a necessity. And so the increase in demand for them is less than proportional than that increase in income. Our objectives for today are to understand cross-elasticity of demand, to use the formula, to interpret numerical values, and to recall the factors that influence elasticity. Today we're going to be looking at peanut butter and jelly, the firmest of friends, when looking at cross-price elasticity of demand, which we so affectionately call XED. And we're interested in the effect of the price change in one good, which will be jelly today, and how that has an impact on the price and the quantity demanded for peanut butter. Now, if the price of jelly increased from P1 to P2, we would see a fall in quantity demanded from Q1 to Q2. And I haven't drawn a supply curve on this graph because we haven't been told why the price is changing, just that it is. Now, we know from our long, expansive history of peanut butter jelly sandwiches that they are complementary goods. You often buy one to go with the other, more so in the US, but I hear it's a pretty tasty sandwich. And so we can understand that if there's going to be a fall in demand for jelly, there will likely be a fall in demand for peanut butter, and it's going to shift to the left. that is, the demand curve for peanut butter will shift to the left as a consequence of the change in price of a complementary good. I'm just popping on the equilibrium points so we can see that initially the price of peanut butter was at PB1 and the quantity was at QPB1. Drawing the demand curve left of the original, I've decreased demand, and we can see that price will fall to PB2 and QPB2. So we've seen a fall in price and quantity of peanut butter. So to calculate XED, or cross price elasticity of demand, we're really interested in the effect of the price of jelly on the quantity demanded of peanut butter. So we're going to write the equation as the percentage change in quantity demanded of peanut butter, or good A, divided by the percentage change in price of jelly, or good B. When the percentage change in quantity demanded is negative and the percentage change of price is positive, we're going to have a negative number divided by a positive number, giving us a negative answer. Another way that you'll see this written is when XED is less than 0, you know that you have complementary goods. And so to complete my chain of reasoning, after my demand for peanut butter shifted to the left, I just need to add in that the price fell and the quantity demanded fell. And I just want to stress that we're looking at the effect of price of one good on the quantity demanded of another. So let's try a quick question to make sure you understand. Due to a rise in the cost of fruit production, the price of jelly rose by 25%. The demand for jelly fell by 5%, and the demand for peanut butter fell by 30%. This question is deliberately phrased to confuse you. There is an intentional overload of information. But we're not going to stress, we're going to recall the equations, substitute in the values that are relevant, and then work out from the multiple choice options which is the correct answer. So XED is the percentage change in quantity demanded of good A divided by the percentage change in price of good B. So we know that the price of jelly has risen by 25%. The demand for jelly has fallen by 5%. We would write that as negative 5. And the demand for peanut butter fell by 30%, so we'd also write that as negative 30. We are interested in the effect of the change in price of one good on the quantity demanded of the other, so we're going to take the negative 30% divided by 25%, and that will give us a negative answer. We don't even need to worry about calculating exactly because the multiple choice doesn't require us to. If we have a negative number to XED, that means we know we have complements. The second part is to know the PED value. We know that PED only needs to be given as an absolute value, and to calculate it, we find the percentage change in quantity demanded divided by the percentage change in price. Now for PED, we're thinking about the same good, and we have two pieces of information for jelly. So we're going to show that the change in quantity demanded was a fall of 5, so negative 5, divided by the change in price of 25, and any number divided by a bigger number will give us a value less than 1, and so we know the PED will be inelastic, which tells us that we have a good that is a complement because XED was negative, and it is inelastic because PED was less than 1. And so we can see that the answer is D. For our second example, I'm moving on to some very well-known substitutes. So the opposite of complements. Substitutes are the type of good that you will buy one in place of the other. So if we are asking what is the effect on Coca-Cola of an increase in price of Pepsi, the first thing we're going to write down in our chain of reasoning is the price increase for Pepsi. I've drawn this with equilibriums showing the increase from P1 to P2. And as we know with demand, that means there'll be a fall in quantity demand for Pepsi from Q1 to Q2. Now, when consumers see an increase in price for the good they were intending to buy, some of them will switch their consumption to a substitute good. So the fall in quantity demanded along that line is the consumers that are switching to either drink water or potentially a close substitute, Coca-Cola. The way this is shown on the supply and demand diagram for Coca-Cola will be an increase in demand shown by a shift to the right. If we draw D2 to the right of D1, we'll see an increase in price from P1 to P2 and an increase in quantity demanded from Q1 to Q2. We are interested in the effect of the change in price of one good on the change in quantity demand of another good. So we write out the equation for XED again. That is the percentage change in quantity demand for good A divided by the percentage change in price for good B, or in this case, the change in quantity demand of Coca-Cola divided by the change in price of Pepsi. We can see that there has been an increase in quantity demand, so we know that the change in quantity demand was positive, and the change in price was also positive. And so a positive number divided by a positive number gives us a positive XED, and therefore we have a substitute, because the price of one good will always move in the same direction as the quantity demanded of the other good. Pause here for you to have a chance to have a go at this you try question. Imagine hypothetically that Coca-Cola and Pepsi both saw a fall in demand as consumers sought to find sugar-free alternatives. The Coca-Cola company could decide to make a series of price drops to increase revenue. Now, the hint in that question is price drops to increase total revenue. We know that if there's a fall in price and an increase in total revenue, then the increase in quantity demanded must be more than proportional than the fall in price. Therefore, we must be talking about an elastic good. PED must be greater than 1. In addition to this, we know that Coca-Cola and Pepsi are substitute goods. They will expect a level of understanding and common sense. We know that substitute goods have an XED that is positive, and if we have a look at the options available to us, we can see that option A has a positive XED and a PED that is greater than 1. It is your turn to have a go at 3 questions now that you've gone through examples and now you try. Question 1, an increase in the price of a PlayStation console by 22% led to a fall in PlayStation games by 4%. What does this tell you about the relationship between the console and the game? XED is percentage change in quantity demanded in good A divided by percentage change in price of good B. We can see that the change in quantity demand was a fall of 4% over an increase in price of 22% of a different good. This is going to give us a negative answer, and so we know that the goods are complements. Question 2. An increase in the cost of production of dairy has led to a 30% rise in the price of butter, a fall in demand for butter of 15%, and an increase in the demand for margarine of 12%. What is the XED of butter? What's the relationship between butter and margarine? What is the PED of butter? Is the demand for butter price elastic or inelastic? And will the revenue from butter increase or decrease after the price rise? Pause and have a go yourself. So XED is going to be 12 divided by 30, which gives us an answer of 0.4, and this time they wanted an actual value. The XED is greater than 0, which means it's positive, and therefore the goods are substitutes. Part C, PED is the percentage change in quantity demand divided by the percentage change in price. Quantity fell by 15% and price rose by 30%, and so PED in its absolute value form is 0.5, which is less than 1, and therefore it is an inelastic good. The price rise for an inelastic good means that quantity demanded will be less than proportional, and so there'll be an increase in total revenue. If you are ever in an exam and your mind draws a blank, you can always sketch a very inelastic demand curve, and you can have a look to see what will be the effect of an increase in price. We can see that the change in price was more than proportional than the change in quantity demand, so the gain was greater than the loss, and so total revenue and the size of that rectangle increased. The very final question. A short-term drop in the price of beef from £3.40 to £3.06 led to a fall in monthly fish sales from 24 million to 19.2 million units. Calculate the XED. First of all, we need to work out the percentage change in price. So we're going to do new minus old over old times by 100. So that's 3.06 minus 3.4 divided by 3.4 times by 100. And that tells us that the percentage change in price was a fall. So we're going to write that down as negative 10%. The percentage change in quantity demand for fish is 19.2 minus 24 divided by 24 times by 100, and that's going to be a fall of 20%. So we're going to see negative 20. we know that to calculate XED, we work out the percentage change in quantity demand of good A divided by the percentage change in price of good B. And so -20 divided by -10 gives us a +2. A positive XED value tells us that they are substitutes. So we know that fish is a substitute to beef. Well done for finishing the lesson, and I'll see you next time on Minute Micro Macro.